Data science, we really see it everywhere in our world. So, with Netflix, with your Netflix recommendations, how it knows what you want to watch. Similarly, right now it's pretty hot with, healthcare and bioinformatics, with, COVID-19 projections, or, even in, sports analytics. So we really see it everywhere, and it's really important to, be aware of such, data science and those skill sets. So, the overall workflow of data science, this is kind of roughly what we want to follow in a project. It's it could change based on the data you have, but usually you want to first start out with framing your question and like the problem you want to solve. And so this helps you streamline your approach throughout the subsequent steps. And once you frame your question, you want to get the data to help answer that question. So whether it's from a database or if you want to scrape it from a website, this is what we want to do to start our analysis. And obviously, once you get that data, it's never going to be in a good format. It's always going to be messy. You're going to have some missing values, and it's going to be unclean. So the next step is to clean your data and diagnose those errors. And that's what today's workshop is going to be. We're going to be doing today's workshop. And then after your data is cleaned, you want to then visualize. And that's kind of like the heart and soul of data science. You want to explore the relationships between your variables, and make any sort of preparation for the next step where you want to then model with your data. So this is kind of where your AI, your machine learning comes in, and you build models based on the variables that you explored. But even though you built your model, that doesn't mean you're done. You want to then evaluate the model to see how it did on unseen data, or in general, if you might have to, pivot your question a certain way or get more data. So this is why this workflow is kind of like a cycle, because you might have to go through this process several times. So for future workshops, as I said, we're going to be splitting this up into 3 major components. So data visualization track, a data cleaning track, and then a machine learning track, as well as many more. And we're going to be coming back to that workflow quite a bit just to like revisit it. And just the thing, if you guys came from a no coding background, that's okay. This is for complete beginners, so you don't have to worry about that. And the learning goals, obviously, right now these technologies seem very foreign to you guys, but we're hoping that, by the end, you'll be very sound, fundamentally sound with these technologies and know how to use them. So, the common question we're going to get, these tracks are going to be in Python and then one in R. So, next week we're going to have data cleaning in R. So the question I might get is, which one should I use, Python or R? And the good thing is for data science, they're both very great tools and they're both very powerful. You really can't go wrong with either. One thing I just will say is, R is generally suited and is, good for people with no prior coding experience, just because it was built for statisticians, which means that, it's very easy for statistical computing. It's really good for beginners in that sense. Not to say that you can't learn Python. The syntax in Python is very easy to read. It's like reading plain English. But the one thing you'll have to learn is the object-oriented programming aspect, which we'll get into. So today's workshop seems a little bit difficult. You can come to the R workshops and still learn the same stuff. So one quick thing I want to say is, you're going to be learning a lot of content, for these workshops. So a good way to digest this information is, not only just following along with the live coding exercises, but also making sure try and practice on your own data sets to really make sure it sinks in. So with that, we're going to now get into the main portion of today's workshop, and that's the intro to data manipulation with Python, right? So again, we're just, I already talked about the workflow, so I'm going to be very brief on that, just kind of where we're at, what we're working on, the importance of it briefly, and then, what a package is, and then, getting into the coding with like the data set and stuff like that. So again, I'm not going to go through this whole thing, but I just want to emphasize that today's workshop is going to be focusing on the cleaning data part. So really just looking at your data set to assess any sort of problems. And then the importance of it is that, like I said, raw data is messy and it might affect our results later on if we don't diagnose these problems. And then I'm going to be saying this word a lot, like, a package. So a package is basically a collection of common functions that are used for, various tasks. So for data visualization, data cleaning, machine learning, these are all very common tasks in data science. So Python actually has a lot of packages that you can use to use certain functions. You do not have to write your own code for functions. Stuff like, calculating summary statistics is all built in. So in Python, the data manipulation package is called pandas, and it's very widely used, and it's what we're going to be using in the workshop today. So here, just follow these things here. I'm going to send this link in the group chat here. Hold up. I'm going to send this link in the group chat. What you want to do is you want to go to this website called Kaggle, and it will take you to where we're going to be downloading our data set for today. So this is just a Starbucks nutritional drink menu data set. So it has all the Starbucks drinks and their various, nutritional information. So what you want to do is you want to make sure you click download here and save it to a file on your computer that you'll have to refer to in a bit. But just go ahead and download it here and save it. And then the other thing that I want you to do is to go to this link here. This is the notebook or the environment that we're going to be coding in. So if you actually click on this link, it's going to take you to this environment. And once you get here, this is important. Make sure you click File at the top here and save a copy in Drive, because you can then work alongside me, and then you can also have your own copy to refer to later on. So go ahead, take a few moments to download the data set, and then get this notebook open and save it to your Drive. I'm just going to give a little bit of a intro to what this environment is, Google Colab. This is pretty much, what we're going to be working in for the rest of the semester for Python. So this is just, so this is your code chunk here. So this is where you write your code. And this is just a text. It's called a markdown cell. That's where if you wanted to type anything, it's like a Google Doc or a Word document. So just to run your cell here, you can just press this play button and it outputs it for you. If you want another code chunk, there's just this plus code button here. You just click that, or you can click this plus text if you want to mark down. Pretty self-explanatory. And then you can type multiple commands in a cell here. So you see here, I've typed multiple commands, and you're not restricted to one. So you can just run this and it will print your most recent one here. And then, or you can just wrap it in a normal print statement, like usual, and that works as well. But one thing that is just I wanted to point out was, like, if you type multiple commands here and don't wrap it in a print statement, it's only going to return the most recent command that you typed. But if you want to, print all of them out, then you wrap all of them in a print statement. So that's just something small to notice. And then, so let's get into actually working with pandas. So first thing we want to do, like I said, when we want to use packages, we need to import them into our environment. So the way we do this is in Python, we say import and the package name, and we say as alias name. So that alias name is pretty much the object that we're going to be referring to when calling our pandas functions. So the most common one is called PD. So I'll go ahead and just import the pandas package here. So you can do import pandas as PD. And so now what we do now is when we run this, it's not gonna show anything because we're just loading it into our environment. So to now actually work with our data set, we need to make sure we import our data into Google Colab. So you can really just copy and paste this from the markdown and paste it here, but this is where we want to go back into our file system and upload our data set. So if you run this cell here, it's gonna tell you to choose your file. So you wanna click this, and it's gonna pull up your file system. So take a few moments, look for your data set. I saved mine here. It's the Starbucks drink menu expanded, and you open it, and it's just going to tell you that it's saving here. And once it says that, you want to go up here where it has our files, and you may have to just hit this refresh button. But once you do that, you'll see that something pops up here, and that's our data set. So that means that it's loaded into your collaboratory notebook, and it's ready to go. So we want to then now actually read it into our Python environment. So to do that, we're going to use the read CSV function here. It's called pd.read_csv, and you want to specify the file path, which is that CSV file, and you want to save it to a data frame object. So I just saved it to df. So we're going to be using this df quite a bit throughout the rest of the through the workshop to refer to it. So if we do, you can name it anything, but I'm just calling it df. df equals a pd.read_csv. And then here you can see that it will show your your arguments. So now you want to specify the file path as a string. So just put some quotes or to like specify that you're going to use a string. And you're going to come up here and you're going to right click and you're going to click copy path. Okay, so now we want to enter this file path into our function. So you can do Command V for Mac or Control V, and you want to paste it in there. So now we have said that we're going to read in this file name and save it to a data frame object. So our data is in Colab and ready to work with. So now that we have that, you see it doesn't print anything because it's just stored to an object. But now we can actually print our data frame and see what kind of output we get. So this is our data frame here. And basically now we're just gonna look at, we can see here that there's some information it gives us. It gives us 242 rows, 18 columns. So pretty much a data frame. In Python, data frame is basically like your normal Excel spreadsheet. Just you can do some manipulation with it in code. And you can see here that along the top, this is your column names or variables that you want to explore. So we have 18 columns, so 18 variables of our data set. And then the rows represent the amount of samples in your data set. So you guys, if you guys work with Excel and stuff, this is very typical. These dots are just to, it's not going to show the entire data frame. So it only shows the first few and the last few samples. So now that we have this, right, one of the most fundamental things we want to do is we want to be able to select a column, right? So we want to make sure that we can select columns in our data frame and subset it to help with our manipulation. So there's two main ways you can do this in pandas. So one way is to specify, so if you treat this data frame as a massive array, you can actually specify the specific column name, right, as a string and pass it into the data frame, and it will return that column for you. But make sure you spell it correctly, or else it won't return anything, or it might throw an error. So that's one way you can do it. Or you can refer to these columns as a property of the object and just call dot and specify the column name. So df.beverage would return the beverage column. So one thing I want to specify here, so we can go ahead and try and use both of these methods. So I'll go ahead and return the beverage category column. So you can do df and then specify that you're gonna go into the data frame and specify the index, which is a beverage category. So that's the name of the column. And if you actually do this and you put the quotations, you can see that it shows all the columns that we can select from. So you can either type it, or I like to just click this and it shows it. And when you run this now, it's going to return that column that you wanted to select. Yeah, the read path. Okay, yeah. So for the read CSV thing, what you want to do is once you uploaded this and you chose your file from your drive or from your file system, it's going to show up here. And once it shows up in your files, you want to do this pd.read CSV function, and you want to get the file path of your file. So what you do is you right click on these three dots next to the file name, and you do right click copy path. And then you specify the file path and paste it, Control V it into the function as a string and put it in quotations. So the function knows that you've given it the exact file path of the data set. So If you have any trouble with that, just put it in the chat again. But so now that's one way of indexing the column. So now we're going to try the other way with the calories. So return the calories column from the data using the dot properties method. So that's just this method here that we're going to use. So if you do df dot, and then we're going to call the calories method here. So if you do the calories column, so if you go like this, df dot calories, it returns the calories column. So this is two ways you can really import or get your columns from your data set. I'm just going to highlight one problem with the second method. So, if you do the dot method, it's great and it returns your columns, but, it sometimes comes in, like, there's issues with it when you try and return a column which has a space in between it, right? Here we have oh, wait, hold on, let me call it df. It's going to return an error, and it says that, this column cholesterol, it's not there. And that's because your column that we had, cholesterol mg, had a space in it. So when you have any column names which have spaces between or white space, this second method of retrieving columns is kind of can throw some errors. So that's why you're going to see me using this method quite often, just because it's safe and it returns the exact column, and you can just spell it correct. If you spell it correctly, you'll return the column most of the time. So now that we have that, we're now going to retrieve the cholesterol column the other way, and you'll see how we'll actually get a good result this time. So if you do df and then specify the column name, so here we can see cholesterol mg, right? And we run the cell. It returns the cholesterol column. So like I said, this is a very safe method of indexing into your data frame. Treat your data frame as a big array and specify the exact string of the column name. So that's how we subset a column. So one thing that I like to do before actually diving into any sort of EDA or anything is to kind of inspect the data, eventually just kind of look at how the data is distributed in terms of the first few rows, the shape of the data, kind of investigating the columns, looking at what kind of properties they have, and then some basic summary statistics. Make sure if you're getting an error, make sure you're importing the pandas as PD, or that could be an error you could also be getting. Yeah, make sure you're importing the pandas function, and make sure you're copying the file path here and you've uploaded it. So one thing I like to do is I like to return the head and tail of the data. This is just returning the first few samples of the data just to kind of see what kind of observations we have. So what you can do is you can call the .head function. So all these functions that you want to call on your data, you can just chain them to your data frame object. So that's why we want to use this data frame object for the whole entire project. So if we call df.head, right? So return the first 5 rows of the data frame. So if you call df.head, here we'll see that we see the first 5 rows, right? So we can see overall, okay, we can see a few, for the beverage categories, the beverages, these are what the first few samples are. But then we can also return the last 5 samples. So you can call it df.tail, which is just the opposite. And we can see, okay, these are the last 5 samples of our data set. So we can definitely see some variability here with the beverage category, the beverage, the type of beverage prep. So, this is just a good way to kind of see how your data is varying. And then one thing I like to do is, this is pretty trivial, but it's pretty important when we get into kind of splitting your data set up, is checking the shape of your data just to kind of see, to make sure what kind of columns you have, or if you've transformed it to keep track of everything. And you specify, return the shape of your data as actually without these parentheses, because the shape of your data in Python is a property of your data set. So for that, you don't really need parentheses. If you get an error from it, that's mainly because you probably put parentheses instead of just calling dot shape. I make that mistake all the time. So it's okay if that happens. So when you run df.shape, right? So let's do this. df.shape, we'll get this output here, right? And this shape returns a tuple. So a tuple is basically a data structure in Python where it stores the first argument as the number of rows and the second as the number of columns. So, we can actually confirm if this is true if we just do df, if we just print our normal data set. We can see that this df.shape returned 242, 18. So 242 rows, 18 columns. It's a good small check to have to keep track of how your data set looks. So now, once we kind of do some initial kind of observations, we can get into actually looking at the columns of your data set and kind of reading into them a little bit more. So one thing I like to do is first, for very large data sets, this is important, is to just kind of return the column names in your data set to see what you have and kind of refer to them later on when you do data subsetting. So for that, again, the columns is just a property for your data frame. So you'll just call df.columns and that will return the columns of your data set. So if we just go, return the columns of the data. So if you do df.columns, right? What it's going to do is it's going to return an array of all your columns. And, this is great. We can read it and we can see all of them, but, it would be nice to get maybe a nicer list that's easier to read. So you can just wrap this df.columns code in a list function. So literally just, if you do list and then within passing the argument df.columns, it will return the same data just in a nicer list. So I like to do this later on. You'll see when we subset more columns or look at columns specifically that, this calling list df.columns is important when you want to copy the exact string for the column name, because this white space here is pretty important when you're trying to subset a column, because if you don't include that, it's going to return errors. So this is just a nice function to have. And then another thing I like to do is I like to look at the column data types. So looking at your column data types is pretty important as well, because it can kind of guide what kind of data cleaning tasks you want to do later on down the road. So, if you see certain columns with strings, you can turn these string columns into integers. A lot of machine learning algorithms require that your columns are in integers or numbers. So this is a good function because it shows your data types of your columns. So if you call the .info function on your data frame, if you .info, it will return the another list with all the columns in your data set and its various data types. So you can see here there's the floats, which is a floating point, which is basically a decimal. We can see we have some columns for integers, which are your whole numbers, and then these objects just represent our strings. And these are these columns we might have to try and turn them into integers later on. So it's just a good function to have. So after we do this initial check, we also want to, explore the columns a little bit deeper to see, what kind of values are within certain columns. So I like to use this when we have columns which are categorical and we only have a set number of given outcomes. So the way we can do this is you want to specify the column name that you want to check the counts of and call .value underscore counts. And here, like I said, we have two ways of doing it because you can call the column name two different ways. Here in Python and pandas, you can see that there's a pattern with how we call functions. You specify the column name and then call any function after that. So this is where the object-oriented programming comes into play. So we can look at, what are the different beverage values and their counts, right? So, I like to, call that list df.columns function just so, we have all the columns ready to, copy and paste into our, when we index them. So, let's, return the beverage values, right? So let's do df and then the beverage and do value underscore counts, right? So when we do this, it returns basically all the different types of values that are in your in the given column. So these are all the different types of beverages we have in our data set. So we can see, we looked at the head of the data, we looked at the tail, but, we only saw a kind of like a glimpse of the variability. And this here shows everything that we can see. So, we can see even the counts of it. So we can see which ones are the most frequent. And this is a good kind of function to have when you want to deal with certain imbalances in like your in your column. So we'll be using this quite a bit. So that's the value underscore counts function. And so now once I kind of look at the columns and get a sense of what kind of data we have, now I want to jump into the numbers and doing some initial summary statistics. So, obviously, you guys might have heard these elementary, summary statistics, like looking at the mean, the mode, the median, the maximum, and the minimum. In pandas, we have functions that can do this for us. And the nice thing is we can do this either for a specific column name, or we can do this for the data frame as a whole. So, we can return the mean for one column or the whole data set as it is. And we're gonna see that here. So you're gonna see this is a very common pattern for all of these. You specify, like always, you specify the column name, and then you call the function that you want to return. So if you want to return the mean of a specific column, you call .mean. If you want to return the mean for all columns in your data set and get a nice data frame out of it, you just specify the data frame itself and call it .mean. So let's see here. What is the average sugar content in the Starbucks drinks? So let's go df, and then if I do this, you'll see, okay, we have our sugars column here. So let's click on that. And you want to call the .mean function, right? So we do that and we see, okay, the average sugar is 33 grams, right? And then we can also see the average of all nutritional information for all of our data. So we can do df.mean. And now we can see that, okay, we have mean for all of our different column values here. And yeah, it's a good way to explore our data. So once we do that, one thing I want to highlight is, we don't see the mean being returned for all of our columns. And, one thing I want to point out is if you actually look into why this is, for example, the caffeine column is not included here, right? So, let's see why the mean is not returned for that. We saw in our data set that the mean was all integers. So let's see what happens when we run this, right? What is the average caffeine content? Okay, well, we got an error, and, this error message here is, it's pretty hard to interpret. So what I like to do is whenever I get an error like this is to, again, call that value underscore counts function to just kind of diagnose what kind of values that may be in there. So it says here must be a string, not an int. So maybe that means there's a string somewhere in there that shouldn't be. So let's see. So let's do df and then look at the caffeine column and .value underscore counts, right? Let's see what kind of values we have here. Okay, so we can see here that in the caffeine column, it says data type int, so it should return a mean, but we can see here that there's two values here which have a string. So, that's a problem because it's not going to return the mean when there's strings or words involved in your column. And that's why this function is so useful, because now I can see, okay, that's why we have an error when we call the mean function. And, this can be something that can tell us that later on, the caffeine, if we want to use the caffeine as a variable in any sort of model later on, we need to diagnose these strings and clean this column before we use it in a model. So yeah, that's checking the mean. And so, returning the median, same thing, specify the column name, .median, or if you want the median for all the columns, you call .median on the data frame itself. So, let's return the median number of sugars. You guys, this is just same thing, specify the column name, and then .median. And we will see that the median amount of sugars in the middle value is 32. And then we can also return the median for all the nutritional information. So same as last time, get the data frame object and then call a .median, right? And so we now see that there is the median for all these various columns. So yeah, so same, for the other two summary statistics for max and min, they do the same thing. I think you guys get this by now. If you guys want to go through and also try and do this yourself, you can, just returning the maximum and the minimum. But, it's the same thing. You're returning the column name, specify the column name, call max, specify the column name, call the minimum. But, this is great, getting the individual summary statistics itself. But, what if we could get kind of like the data frame statistics for the entire data frame itself in like a nice format, and maybe even just get more than just the mean and the median and the max and the minimum. What if we can get the standard deviation or other summary statistics, which are very useful for us. So pandas has, along with these individual summary statistics functions, we can also return the data frame summary statistics using the .describe function. So what this does is, you'll see, you can do it on the column name itself, but I usually only do it on the data frame because it gives us all the columns. So you can return the summary statistics by just calling the .describe function on the data frame itself. So return a data frame of summary statistics using .describe. So we'll do df.describe, and we'll run this here. And you see here, this is a very nice, output we get, as opposed to the other things we saw. We see, all our various columns, and we see your mean, or your 75th percentile, your 25th percentile, your median, your max and min, all these nice summary statistics in one format. So actually, these these functions above, I actually don't use as much. I like to use this describe function because it returns everything at once, and I can just check and see what kind of what kind of variability is within our columns. So yeah, so that's summary statistics. And then another thing I like to look at is, if I'm doing any sort of regression or anything like that, using a correlation matrix. So a correlation matrix will basically return a data frame with a correlation coefficient for each of your variables and another variable in the data set. So you'll see here that when you call it, you call the data frame and then you call the .core. So it will return the correlation matrix for the data set. So if you call df.core, it's going to see here, it's now going to return, you'll see all these numbers here. So this is actually your R correlation coefficient. And, just a reminder, correlation coefficient is on a scale from -1 to 1, 1 indicating a strong positive, correlation coefficient, and -1 being a strong negative. So, you can, I like to look through this and see what kind of relationships would surprise me, what I would expect. Obviously, you can't imply causation, but I like to see, what kind of relationships there are here. So, let's say you want to look at the difference between calories and the sugar, right? So in order to read this, what you do is you find, your data, your calories column, the first column that you want to look at, and then the other column that you want to find the relationship with. So calories and then sugar, and then you see that they meet at this value here. So, they have a pretty strong relationship in 0.9, and this, this could make sense because Starbucks drinks with, a lot of sugars, or drinks in general with lots of sugars, have more calories. So, just take a look through some of these, what will what's like surprising to you or anything. This right here, this one, that's just because it's comparing the correlation between, the same column. So just ignore that. But yeah, this is like some good initial exploration we can do with our data frame before we actually get into the main thing, and that's transforming your data. And so like transforming your data is basically, you don't always want to work with the data set you read in, right? This data set was only 18 columns, but some people, are getting their data from databases with hundreds of columns, right? And then what are you going to do? You're not going to use all your columns for, a specific machine learning model or any sort of exploration. You want to get a subset of it to work with, or, maybe you want to rename certain columns. So far we've been dealing, I don't know about you guys, but it's been pretty annoying dealing with all these, these different columns so far. So, what if we can rename them so it's easier to work with? So to do this, to rename our columns, pandas has a .rename function. So just pay attention here, because this is kind of some core Python fundamentals here that I want to specify that may seem kind of foreign, but so you call the df.rename on the data frame itself, and you want to pass in an argument here called columns. So this indicates that we want to change the columns of our data set. And this data structure here, this is called, in Python, it's called a dictionary. So basically what this does is that it maps a key and a value pair. So basically, whatever is in this part of the dictionary will map to whatever's on the right side of the colon. So the left and right, are go together. So for those of you who've taken, CSE at OSU, Java, it's the same thing as a map with a key value pair, except in Python, it's called a dictionary. So what we want to do is when we pass in the columns argument, you want to specify a dictionary which holds the various column names and their specific columns that we want to rename them. So this here would be one pair. So it would be your old column name on the left side of the colon, and then your new column name on the right side, right? And that will then change your column after we output it. And then so that's if you want to return, change one column, but let's say you want to change multiple columns. So all you have to do then is just make sure you separate the pairs with a comma in your list. So you have your dictionary, you have your first column name, your new column name, and then you separate it with a comma, and then you have your new column, another column that you want to rename, and then you map the associative column name to that, and then you can keep going, and you can do it for your whole data set if you want it in one line of code. So that's the rename function. And then I wanted to I forgot to touch on this earlier, but in Python, for any sort of functions that you may forget arguments of, there's a nice help function that you can use to return some documentation. So I like to do help, and then in this case, the df.rename function. So you refer to the object that you're using in this case, it's the data frame, and you can call the rename function. So what this does is it just gives you a nice helper to what the function is, what kind of arguments it has. So here you can see, aside from columns, we can replace the index of a data set or stuff like that. So this is just a nice function I like to use in case I forget any sort of function name or its arguments. So with that, let's get into renaming these columns. So I like to first get a list of the column names, because if you don't actually specify the column names correctly, it's not going to change it. So let's do the same command from earlier. So let's get a list of our columns. So the way we did that, right, was the df.columns, and then you wrap that in a list. So df.columns, and then you wrap that in a list function. And what that will do is now we have the columns we need. So why I like to do this, I touched on this earlier, is because these spaces, you need to make sure you specify them in your renaming, or else pandas doesn't recognize the column that you're trying to rename. So let's rename this protein grams to protein, right? So how would we do that, right? So you want to call the .rename function on the data frame itself. So df.rename, right? And then we want to pass in our columns argument. So now we're going to tell this function that we're going to rename our columns. And then we pass in the dictionary. And the way we tell the dictionary to map our values is we say on the left side, we specify our column as a string. And on the right side, that's the new column name. So on the left side we're going to be putting the protein grams. So this is the column name that we had before, right? So you want to copy that. I like to just Command C and paste it in here. So Command V. Make sure you just copy whatever between the quotations and then paste it here as a string. And then we want to rename it to protein, because this is what we want to change the column name to. So let's do protein. So we've renamed it from the original protein grams to the protein column. So now when we print this, we're going to see that so originally we had the protein grams column here. So now we've, changed to protein. And so this is good because now when we refer to this column later on, we don't have any issues, specifying the specific string name or accounting for this white space here. We can just call the protein, the protein value, So now, if you want to just call columns based on the index method or the dot method, you don't have to worry about the spaces here. So this is why I like the rename function. So now let's do another one, right? So let's try renaming the trans fat gram column to just trans fat. So let's same thing. So df.rename. So since we've already changed our protein column, that saves it to that data frame object. So we don't have to worry about renaming the protein column again because we've run the command ahead of it. So let's do the specify the columns again. So columns. And then this time we're going to be doing the trans fat column name. So here, just copy this and specify the older column as that on the left side of the dictionary, and then your colon. And then we want to then put in the new column name that we want, right? So trans fat. And then if we run this now, you'll see that our trans fat column now, see, this is nice because we can see the change in our trans fat column from here to here. So it's changed our column completely, and this is definitely what we want. So this is more of a challenge, but let's see if we can rename the caffeine column, the sugars column, and the saturated fat column all on one line, right? So you guys can go ahead and try this if you want, but I'm just going to type my answer, and you can go along with me, or if you want to do it right now, you can go ahead. But for this, we want to do what we did before, right? We want to separate the individual pairs with a comma. So same thing, called the rename function, right? And then we say columns, and then we have a dictionary, and we do the first column name. So that was the caffeine column. So let me just, for reference, have the column names here again. So the caffeine column, which is here. So copy this, and then paste it here. And then we change it to the other one, which is just caffeine, right? And then now we want to rename another column. So we do comma, and then I like to put a space so I can show that there's a separation. And then now you want to do the sugars column. So get it here, just copy this, and then paste it here. And then we can do the sugar, rename it to just sugars. And then we specify the third one that we want to do, and that's saturated fat, right? So let's do another comma, space, and we specify the old column name, which is just the saturated fat grams. Copy, and then paste it here. So that's our old column name, and then same thing, make it our new column name, which I'm just going to call saturated fat. So you see here, you can see the individual pairs. So those pairs map to the old column name and the new column name. So now when we run this, you see here that our caffeine column has been changed from caffeine G to caffeine. The sugars is the way we want it, and the trans fat is the way we want it. So saturated fat is the way we want it. So we have transformed our columns to the way we want them. So now, once we renamed our columns, right, and you could probably go through and rename all of these, but another thing I want to touch on is, we want to also, like I said earlier, work with a subset of our data. We never want to work with our data set as a whole, especially when we have a lot of columns. So the good thing about subsetting multiple columns is that, we already know how to subset one. So subsetting multiple is actually, not that much different. So you remember, returning one column, we treat the data frame as an index or as an array, and we index it with the specific column name itself. So now if you want to return multiple columns, what we do is we specify an array of multiple column names that we want to get from our column or from our data set. So let's say we want to take, these 3 columns, right? You want to make a separate array and specify those strings as column names and pass that array in. So, this might seem a bit confusing. So what I like to do sometimes is I like to just, store a separate array and just call it, array, and then specify the specific column names. You can do it this way too. This is just 2 steps, but you can tend to make less errors sometimes. You might miss a bracket here, but you specify the array with your column names, and then you can just pass that array in here. It does the same thing. One thing I like to do though is, and which is a good practice, is if you're renaming, so renaming columns is fine, but if you're going to be subsetting your data, especially when you want to work with various different subsets, it's always a good practice to get the subsetted data and save it to a new object. So I like to have the original data frame object just because if I want to look at it, but saving it to a new object is good, especially when you have multiple subsets. So let's do this here. So I'm just going to call the new data frame just new df, right? So let's say I want to look at the beverage category, beverage prep, and calories column, right? So let's do that. So again, let's just return our columns here, see what we're working with, and then let's specify our column name. So I'm just going to call it column array, column R, or you can just call it array, and then we're going to get our specific columns names as a string. So let's get the beverage category. So beverage category, I'm just copying what I see up there. And then the beverage prep. So beverage prep. And then the calories column. So calories. And so now this is the array of columns that we're going to be subsetting from our data set. So now let's call our new variable data subset. So this is our data subset data frame. So this is a new object that we're making from our original data frame with just subsetted columns. So to get those from the original data set, we want to still reference the original data frame as always, like we would specify any other column name, but now we want to just pass in that column array. So column array. And so here you see we've saved it to a new object, and then let's print out the output. So if you do this, you see here now we have the subsetted columns and we have our new data objects. So we have 2 data objects in our environment. We have our original data frame. So, I just want to show you guys what happened to our original data frame object. It's still here, since we've subsetted them, they're still in the original one, but now we just have another one we can work with. So we can, do some data visualization on this if we wanted to. So now let's create a new one. So let's say I want to look at just the beverage category and beverage prep columns, right? So, let's say I want to save this as bev info, right? So I'll show the other way here. You can specify as an array if you want, but the other way you could do it is just do bev info. And, we want the beverage category and just beverage prep columns. So let's do the df, and then I'm going to specify an array, and then let's do the beverage category, and then the beverage prep. So now if we print this out, right, we're going to see we just have another object called bevinfo with our beverage category and beverage prep. You could have actually also subsetted it from this column here. So that's the nice thing about pandas is you can take columns from whatever data set you want and subset it from wherever you want, and you really will not run into any errors, and they will still keep the same format. All you have to do is make sure you specify new objects. So, I could have even, instead of df, let me just show you. If I just, because this data frame also has the beverage category and beverage prep. So let's say I want to refer to the data subset column, right? Data frame, right? So what I just did was I just took a subset of another subset of data frame. So you can do that as well. So here's, you can try this too. So you can create another object here, bev nutrition, and select the beverage and calories column from the data subset. So here we're working with the data subset column. So I can even list the column names from data subset. So if I want to know what columns are in our other data objects, I can just run the same command, list, specify the data frame in the columns. So here we want the beverage prep, or the beverage prep and the calories. Okay, let's do that. Let's take the beverage prep and the calories. So let's call it bev nutrition. So bev nutrition, and let's do, I'll do it the other way. So let's do array, and then let's call it the beverage category. And then let's do the calories, because let's say we want to look at, maybe do some EDA and exploratory analysis on how the calories vary for each beverage. So we do that, and then we, we're taking it from the data subset data frame, and let's say we want to then pass in that array, and we run this now. We've now subsetted these columns from our data subset object. And now we have a smaller subset. So now we have the beverage category and the calories data frame, right? So now we've just created 2 new data frames, or actually 3 new data frames, just from the massive one we have. And just to show you guys, our original data frame is still good. Our data subset, that data frame that we have just subsetted from twice, that one's still saved. So, this is the nice thing about data manipulation and data transformation, is you want to be able to take the big data frame you have, and then pick the specific columns from that data frame and save them to specific subsets, so you can use them later on in your project. So, yeah, so that was the first workshop in Intro to Data Manipulation in Python. This is a recorded workshop, so if you wanted to refer to this later, or this notebook, you guys have saved a copy of this, you can go through this. You can upload a new data set if you want and go through this exercise. But that's the first workshop of this semester. We're going to be having a lot more. So here are just some further resources for Python in general. You can, this Python for Everybody, if you guys want to just learn general Python programming, Free Code Camp is a great place for that, or Introduction to Data Analysis with Python is another good course. Kaggle is a great place for you to not only get data sets, but there's free micro courses in that too. And then also, if you're into books, there's a Python for Data Analysis. So this is the this is our first of the other 3 data manipulation courses we're going to have. So we're going to have intermediate data manipulation in Python coming soon. But yeah, other than that, feel free to follow us on Instagram and get connected. If you have any other questions, please send them in the chat, or you can, if you join the Slack, you can send me a message as well. I'd gladly be able to help you guys. Seems like I've got a question here. Yeah, so these recordings will be going up on the Carbon page, and I will actually be uploading this PowerPoint presentation as well for you to look through. So we're going to be getting this Carbon page up and ready, so you guys can get access to these resources and be connected. So yeah, so this is the first workshop. Next week, we're going to be having the same thing, Intro to Data Manipulation, but we're going to be having it in the R programming language. So yeah, that was the first meeting, and I hope you guys learned a lot. So thank you guys for coming.